All right, it didn't quite like that. I'm just checking to see if the inserts are still alive. Yeah, they're good. It's good cut on the floor. Let's try that same cut across the part. Now that went much better, and the inserts are still alive. The only thing I did different here was actually lock the quill and hydraulically lock the other two axes I wasn't using from the control panel. Let's try that Z direction cut one more time. Yeah, same as before. The cut on the floor is perfect, and the wall's got some chatter in the Z direction. Sure, that's a bummer, but that's why I'm doing these tests. This is why I'm trying to resurrect this machine before sacrificing it to the CNC gods. This tells me, well, I don't know what this tells me. Either the vertical head's got some play in it, maybe I should have checked all those bolts, or the actual way does. Like the whole head of the machine might need, I don't know, its gib tightened. Again, a step at a time, but for now, let's do some fooling around. I still see a little bit of chatter, bit of undercutting there, so there's some flex going on somewhere. That's a solid carbide end mill. Maybe it's still coming from the Z-axis, though the part was sticking up like a diving board. Okay, maybe not your usual diving board, but you know what I mean. Note also these were all climb cuts, and all designed to be about in the 1 to 1.5 horsepower range, maybe closer to 1.5. Those were some pretty decent chips. This mill has a 3 horsepower spindle motor, so I'm somewhere in the middle. All in all, I'm satisfied with what I'm seeing. Rather, I have a better idea of how the mill is doing, which is the whole point of these exercises. Sure, some of this is new toy syndrome, I'll give you that, but I wanted to know exactly what kind of boat anchor I was dealing with before putting too much time into cleaning and converting it. You don't want to spend a year CNCing your boat anchor only to find out that it floats. Anyway, you probably came here wondering what was wrong with the Z-axis. Well, it's a little embarrassing. I had it turned off. Just ribbing you. But the real reason isn't much better than that. The head was pushed so far back that this screw was no longer in that nut. So the Z-axis was completely disengaged. And give me some credit now, I did consider that. When I tried to move this top part, it wouldn't budge, not an inch. And there was oil getting to the top, it's oozing out all around the ways. So I moved on, assumed it was something else. But last night, after filming the bit you saw yesterday, I was standing here just staring at the machine when those absolutely filthy limit switches caught my eye. In particular the dogs, or the bumpers that trip the switches. They were both on the wrong side. I snapped a photo with my phone. Sure, stops can be moved, but it reignited the thought that the top was simply disengaged. And it took me the better part of an hour to get it sorted. I couldn't move this head with a 10-foot pry bar. I resorted to having to use every last one of my welding clamps, big C-clamps, something that could span from the front to the back, blocked up front and back with some wood, and just kept cranking until it squirmed a bit. Something must have gotten bound up in here. Maybe this uses tapered gibs and they'd locked up. I don't know. I kind of feel bad strong-arming it now. I'm willing to bet whoever rigged this machine, in order to be able to get a handle on it for lifting, probably put a belt or a chain through the column, had nowhere else to get a hold of it, and sent the head all the way back, past its stops, and lashed under that. Absolutely criminal, I tell you. I've got movement in all 3 axes sorted. I even went to the trouble of sorting out a new power supply for the controller here. I mean, I figured at this point might as well push it into overdrive. But turns out there's a problem with the Y-axis scale. I'm getting DRO feedback on X and Z, but Y gives me some weird overvoltage error and the controller sees gibberish. I might have a dirty scale or reader head, I don't know, but I'm not going to burn any more time with it. I added some more hydraulic fluid to the tank. Screw around with that electrical pressure switch thing I showed the other day in the back. Now it doesn't make noise anymore. The hydraulics are live and that infernal racket is gone. Of course, if I keep screwing around, it kicks back on occasionally, but it's better than before. There it is. At this point, I think I've got a good sense for how this thing is doing mechanically and feel better about proceeding with the conversion. More to come, and thanks for watching.